guys, and welcome back to this second episode of my Computercraft tutorial series. In this episode we will be doing a bit more advanced on the terminal things, like with colors. As you see, I've upgraded my computer here. And today's contraption is basically a liquid sensor thing, so let's just show that real fast. Okay, so here it is. It's an XYcraft tank with liquid sensors and bundle cabling connected to my computer. And I created this program to show how much fuel there is in the tank. So let's just give this some fuel so we can see what happens. Here you see it will continuously update whenever it gets a redstone signal. So this liquid sensor will give a redstone signal when liquid hits them. So when you see now that's on and the bar has updated. And it will continue doing that. So now it should go again. There. So this is what we're going to create today. It's not really that hard, but it's a bit more advanced in the redstone things and a bit more with colors and advanced computers. So let's get to that. Okay, so what is the advanced computer? What does it do? Well, basically it's makes it able to use colors in your programs, so we can make neat GUI applications and stuff. So how can I use this? So let's edit an example program again. So to set the color, you do term.set text color. So it's not really that hard. And we need to use the colors API, which you can look up on the Computercraft wiki. And colors dot, let's make it red. And then we do term dot write, which is basically the same as the print function, except it doesn't go to a new line. And yeah, that's basically it. And it's simpler to use in GUI applications. So hello, like so. And that's basically it. So let's run this. Hello, and in red. So let's add some more to this. Let's add a background color. So to do that, you just do set and background color, and again the colors API. So let's make it lime. Why not? So if I run this again, hello, and in lime. So how this coloring works is everything after these lines will become that color. So if I do a new line here, term.write and YouTube, this will also become lime and red. So you need to change every time you write something new and you want it in a different color. Obviously there is a way you can make this a lot simpler than having to write this all the time. So let's go into that now. How we do that is basically with functions. A function is basically a block of code inside your code, so you can run it a lot easier. So to make a function, use write function and then the name of your function, which can be anything you want. So let's just call this function draw. And let's just make it write hello. And let's make it also in another text color. So term.set text color and colors.red. And when you run this program now, nothing will happen. It's basically just an API at the moment. So to make this part of the code run, you have to call the function, so draw, which was the name of my function. So now it basically does the same as when we did it last time. And this isn't really that special right now because you can't really do what the function is good at. It's not dynamic, so let's make it like so. So if I write text here, this can be anything. This is just a variable name. So I just call it text, like so. Now I have to write inside here what I want to write. So hello YouTube. So now basically this text variable it's turned into hello YouTube, and it will print hello YouTube instead. So hello YouTube. You can also go into the Lua program, and now I can use the function I just created, so draw, and I can do something else like what are you doing again? And it will write that. So that's pretty neat. So let's add some more customization to this. Let's make the color customizable. So color, just another variable which can be anything. And to be able to use this color at the moment, you have to write it like colors.red like this to make it work. So let's change that so the user can write the color in a string instead. So to do that, we convert whatever he writes or she into the colors API. So color equals colors dot, no, dot, not dot, like so, and color. So this will convert the string color into the colors API. And then I'll set the color. So as you may also notice now that I can click around with my mouse instead of using my arrow keys, which is really nice. So now I can write this in blue, for example. So this is obviously a lot simpler than writing colors dot and the color. Now I can just write like this. So let's run this again. See, now it's in blue. So let's make it even more customizable by setting where you want to write it. So let's make a position variables, position X and position Y. And then we have to set that position. So set cursor pause and pause X and pause Y. So like that. Whoops. Ah, of course. Now I forgot to change this down here because now these values has to be in this function or it will give an error. So let's add positions. So let's make it 5 and 10. And if I now run this, hello YouTube, and in that position. So this is pretty powerful it's much faster to write stuff, and when you're making big applications, functions is really the way to go. So instead of writing this all the time and the code gets really long and unreadable, it's just draw like so, and you do all of that just by one line. Another thing you can do with this is make some of these values default, so we don't have to write them. So let's do that. So the text, we don't want that default because that's weird. So let's make the color a default. So color equals color or white. So what this does is if the user writes a color, then it's that color. If you didn't write anything, then it's white. And do the same with pos x equals pos x or 1. Pos I equals pos y or 1. So now if I remove this part, like so. And I'll just write another thing here, so example, why not? And let's make it blue. And let's make it on line 2. That's not line 2. Line 2. And let's... there, line 2. So now it will write hello YouTube in white and up in this corner, and it will write example under in blue. So, oops, what did I forget now? Plus x equals plus y plus. This should be okay. Line 6, okay. Ah, so be careful. Simple as that, and you'll have an error. So hello YouTube in white and example in blue. So this is really simple and makes programming a lot easier when you make functions for different things. Like if you want to send something over the RedNet or something, then you can write that into a function and don't have to write everything. I'll get back into what RedNet is in the later episode, so don't worry about that now. But let's go out and look at some more advanced Redstone API. Okay, so here I've set up a bundle cable setup from Red Power. And if you don't know what bundle cable does, it's basically one line of redstone, and it can output in different ways. So let's show this. As you see here, it's the white one, so this will output over there in the white one. And this is the magenta one, so this will go there. So it's a really neat way to send redstone signals. And you can do a lot of advanced stuff with this, like that one. So let's show you how this works on the computer. So let's first go into the Lua program, and this is the Redstone API, so RS and set. And instead of set output, we do bundled output. And again, which side, so back. And then the color we want to send the signal to. So again, colors API, and let's do the white one. And now this will turn on. And if I do again with orange, oops, orange will light on, but white will go off. And why is that? Well, when you send a color through this bundle cable or with a computer, it will only send to whatever you wrote. So to send in multiple colors, you have to do another function, which is colors.combine. So let's make a variable contain our colors. So custom color equals colors.combine, and which colors we want. So colors.white and colors.orange, like so. And then we set bundled output back and custom color. Now both will light up. So this is basically how you do this. Also, you can write this in numbers if you like that. So rset bundled output back, and for the color white, it's 1. So this will light up. And if I do 2, orange is on. And if I do 3, both of them are on. You may thought that magenta is on, but no. This is basically a simple addition. So this is 1 and this is 2, and to light up both, it's 3. So if I do 4, this will light up. See? And if I do want to have magenta and the white one, as you know, white is 1 and magenta is 4, so that should be 5. And yeah, it works. So instead of doing this and writing all of this all the time, we can write this into a function like we did before. So let's look at this program I made. Very simple. First, the custom color, as I wrote before in the Lua program. Basically set this to 0, which is no colors. If you do rs set bundled output back and 0, it will turn off all the outputs. So this is basically no color. And then function set color, which is the function name, and I want the color and which state. And then again I turn the color into colors, or into the colors API, so you can just write turn on white and true. And then I check if the state, if it's true or false. So if state equals, or if you don't have an equal, and whatever you want it to be equal to here, it's basically is the state true or is it false? And this is if it's true. So if state is true, then I'll combine the color. So then I add whatever the user writes into the color to the custom color variable. Also continuing having whatever the color I wrote before. And if state is not true, then it will remove that color. So colors.subtract will remove that color from the custom color variable. And then I'll set the bundle output so it will update. So let's run this. Lights, and then I go into the Lua program, and I need to write set color and what color I want. So let's just do pink and true. This will light up this one. And now I can set color, and let's do yellow and true. And I can add another one and true. Oops. And to turn them off, it's doing the same thing. And let's turn off the yellow one and false. So this way you can create a simple program with lights and turning it on and off. Much simpler than writing all of the things I did before. So functions are really the way to go. So another thing you can do with bundle cables is get input. So I'll just change this up real fast, and so be right back. Okay, so I changed the lamps with the levers instead, so I can test the input instead of the output. So to do that, let's go into this program again, and then it's rs, Redstone Api again, and test bundled input. So this will basically test if the redstone is on in that specific color. So if I write back where the cable is on, and which color I want to check, so colors dot, let's check the yellow one, that should be true, and it's true. And if I test the light blue one, that should be false, and colors dot light blue, and it's false. So this is how I did that contraption over there, just checking if it's true or not, and then converting that into the value. So this is basically, yeah, it's really handy to make cool contraptions. So let's go to the contraption that we made today and see how that works in more detail. Okay, so let's get back to this contraption and see how this works. So let's look at the code. So edit liquid. Okay, so first here you probably haven't seen this before. Well, what this does is saving the terminal size, the x and y position, to the x and y variables. So now I know how wide and tall the screen is, so I can use this later for my GUI to make it dynamic, so it will work on all monitor sizes. And then this function is probably already known, basically clears the screen. And then I have a draw function, and what this basically does is first it clears the screen, and then it writes all the stuff that won't change. So it will write the water level text, that will always be water level, so I don't need to draw that multiple times. And then here it draws the progress bar. So it draws it in the color white, so it's basically like the background of the progress bar. And here I just do some simple calculations to, I want it to start from the 2, and I want it to be in the middle of the screen, and here it's the middle of the screen and 1 down. And term right, here is a string rep. What this does is it will repeatedly write whatever you written here as many times as you say here. So instead of writing like that many spaces that I want, I just use string rep and how many I want. So then I just do the x minus 4 because there's 2 here and 2 there, so that's the length of the bar. So that's basically how all the static stuff gets drawn. It's just, now you obviously don't see it because the white bar is under the blue bar, but water level here is part of the draw function and the white bar. So let's get back. And the reason why I do this is because it just saves computer some processing power, kind of. You don't need to write this all the time, so that's why I have it in my own function. So here I have update progress, and what this does is draws the progress bar again, so it's basically a copy paste of this, but it will be in blue instead. And also the length of the bar will get determined here, which is 2 other functions. So we'll get back into what that does, but it basically gives a number, so it will calculate how long the bar should be compared to the current water level. So let's continue so we can see those functions. Here is basically a function that we did just now, like back here. I just wrote this into a simpler function. And this function will get the liquid as it says. So as you see here, if get yellow back is true, then level is 5. So if the yellow one is on, then it's on max level, level 5, since it's 1, 2, 3, 4, 5. And an important key here is that I got from top to bottom here. So first yellow and then white at the end. If I would have done it the other way, I had to check like every color to determine that. So with liquid, you know that if the yellow is on, then it's full. All the others should be on. So that's basically what this does, just determine which liquid sensor is on. And then here is the first function we saw before, a water bar. And what this will calculate is how long the bar should be. So first there, the input variable is f. That's just random, and then I'll just set it to be can be a default value of 0 if none is inputted. And here is basically just calculating how long the bar is. So it's x minus 2 and minus 2, so the length of the terminal minus 2, and whatever that is minus 2 again. And then again, this is basic percentage calculation, so this shouldn't be so hard. And then I check, here's probably something you haven't seen, but that means if it's greater than, so if bar is greater than bar length, so if whatever this becomes is greater than the bar length, so it will go out of the bar length, then it should be bar length. I don't want it to go past the progress bar, I just want it to go to the end of the progress bar. You could also do this won't work in this program, but that's less than. So if bar is less than bar length, then do that. Also you can have like so. So if it's equal or greater than bar length, and if it's equal or less than bar length. And I went greater, yeah. And then end, and then the function returns this value. It's basically math.ceil, so it will round that number, so it won't get any decimals. It will round it up. And then it will return that value. So when I launch this function, it will just return a number. So if you look back here then at this one, then you'll see water bar, which is the function, and it wants the fuel or water level as input, and we get the water level from this function. So then water bar and this get liquid will return that number to the water bar, so water bar get liquid. So that's a simple way to add those functions together, kind of, and get a new or much faster output. And here is the actual program that runs all the time. So first it will draw, and then it will go into the while loop and loop eternally. So first it will update the progress and sleep 5 seconds, and then update the progress and sleep 5 seconds, and update the progress and sleep 5 seconds. So it will continuously do that all the time. So that's really all there is to it. So this is probably the hardest part to understand for some of you, but I could probably, let's show you that in the Lua actually. So I just have to run this so I get the Lua commands. So get liquid, so that returns the number 5. And if I do water bar, was it? Yeah, that will return the length of the progress bar. So it will calculate in percentage how long it should be. So if I do water bar again and then 1, and it'll see it is 10. So it has to go 10 levels to make this look neat. So obviously when you see like 2, it's 19 and 29 and so on and so on. So you see here that I have to use 1, 2 and 3, and 5 is the maximum, so that should be all the way. And you see the get liquid will return those values 1, 2, 3, 4, 5 and 0. So when I do water bar and get liquid, that will return 47 as well, because this is 5, so water bar 5 is 47. So that's how that works. So if you like this video and want to see more, please subscribe and like, and see you another time.